Hello, everyone.
Make sure they can hear you.
I'm Fernanda Osborne, and we are here today to talk to you about how Helical is a great solution for seismic application, and more specifically, how we got our City of LA approval to use helical piles under seismic zones Z, E, and F. But before we get started, who here in the crowd is aware of the City of LA approval? Raise your hand. We only have okay. Let me formally introduce myself. I'm Fernanda Osborne. I've been working with Hubbell Power System for 3 years now. I'm a civil engineer, EIT. I manage the sales for Chance for the western of the US and Canada. And I have, prior to that, 6 years experience with sales on Deep Foundation as well. Gary Seider that is going to be co-presenting with me. He has been with Hubbell for 36 years. He is the engineering manager for the civil construction group. He's a PE registered in the state of Florida, Missouri. He's a former chairman of the Helical Tieback and Committed. He is a holder of 8 US patents and author of several technical papers, magazines. So Gary is the guy here. If you have been coming to DFI, you probably know him. Let's talk now about the LABC, that is the Los Angeles Building Code. For many years, the City of LA limited the application of helical piles for remedial repair of existing buildings only. The reason why is because they thought the helical piles could not perform as well under seismic conditions, under lateral loads, and until we are able to prove them wrong. After several years working with the City of LA and with the help of DFI, Chance helical piles are finally approved to be used in new construction for both residential and commercial application in the City of LA. Some of the conditions of use here. In May 2022, we had to revise our ICC report, ESR 2794, to include seismic category D, E, and F. And this was one of the requirements of the City of LA because they made us to retest all our already ICC approved helical piles to make sure they could resist lateral loads. Other conditions of use, you must have a soil report, continuous inspection. You need to have test piles, and 2% of your pre-production piles needs to be tested as well. Also, 116 inches of corrosion loss. Get it? I think it's...
I'll go ahead and give a little bit of the details behind that. Is this the clicker? Can everybody hear me okay? All right, good. Fernanda was being a little bit undefined. We've been working at this for 30 years. So that's sometimes what happens when you finally get some jurisdiction to allow the use of helical piles is certainly rewarding. So Fernanda mentioned that you need an ESR report. And so what we tried to do was focus our attention on the helical products that we could evaluate to what was referred to in the industry as AC 358, which is a building code. It's a evaluation process or acceptance criteria for helical piles, specifically for helical piles. And they allow up to what we call certain pre-qualified sizes, and that is up to shafts, helical pile shafts up to 4.5 inches in diameter. So we focused ourselves on those pre-qualified sizes, and there are smaller ones than that, and I'll show you some of those. So as an example, this is the type of helical pile systems that we evaluated. It uses structural grade materials. In this case, it's a 4.5 inch diameter shafts that can develop load capacities, well up to over 150, 160,000 pounds of axial capacities. So the big crux with, among others, but the City of Los Angeles, with lateral capacities during seismic events. And so that's where we had to focus our attention in terms of how we got our products qualified in seismic categories D, E, and F. So this is kind of a very busy slide, so I apologize for that. And so if you look at it, it's kind of broken up on the left and the right-hand side, relating to different seismic design categories, A, B, C on the left, D, E, and F on the right. And if you look at it, it gives you some various informations related to lateral capacities. It also gives you allowable drift or lateral displacement or deflection at the pile surface or pile head. It also is talking about things such as the depth of the first initial point of zero deflection, and also then the overall depth to where the slope of the pile length is basically zero, meaning that all the lateral loads have been dissipated. That's what we refer to as the length or H there and that. We're also then decided how are we going to relate this to some type of standard or something we could relate to with respect to what's in the code. And we decided to use this table from ASE 7, which deals with allowable drift or allowable story drift of a structure. And if you can see there's various types of structures identified, A, B, C, and D. A categories have to do with most structures that are designed to accommodate some displacement or movement. The other categories, B, C, D, particularly B, is more for rigid masonry type structures, not as obviously capable of resisting lateral forces. And then, the categories kind of break down from there. So the one that's the most strict or the one that has the least amount of story drift allowances of the masonry structures. And so we thought we'd use this as our basis for saying what can using our products how they can effectively be used in these types of buildings. So if you look in the column, and I wish I had a mark could show you what I'm talking about, the numbers on the far left are giving you the actual allowable capacities of these piles. Again, you're not breaking records on lateral capacity, but at least it's telling you what they're capable of in 3 different types of soils: stiff, firm, and then soft materials. And if you look, the main differences on the seismic side is that the lateral deflection, or the green column, is what's being allowed at the pile head. And so and you can also see how the lengths down to the points of initial deflection, or also to where the slope on the shaft is zero, lengthens as you go down the shafts. And then we're comparing them again to that ASCE 7. That's what the 0.01H or 0.011H and the 0.009H, et cetera, are. So what it kind of boils down to is you can summarize that in very stiff soils, they can be used in the category A, but then on others, they can't be used. But the interesting part is as the soils get softer, they can be used in multiple categories. But the trade-off is, of course, you don't have much lateral capacity. But again, that's just the way it works with the shaft sizes. But it does demonstrate that they can be used to resist lateral loads, which has been the big problem that the city of Los Angeles had for a very long time. We've included all of this in our design technical manuals. And if you haven't already been by our booth today, we're 4, what's our booth number? I can't. Anyway, we're kind of at the end here at the central aisle. If you want to, you can sign up for a free technical manual, which details this in in much more time than I have today to go through all the specifics of what I'm talking about with these allowable lateral capacities in these seismic design categories. So you can register yourself, you get a free tech manual, an actual hardbound copy of it if that is what you would like to have. Some of the other shaft sections that we've evaluated the same way are some of our 3.5-inch diameter shaft sections, and we also have a couple of 2 7/8. These are the higher volume type helical pile products that are typically used in this industry. So I'll turn this back over to Fernanda, and she'll talk to you about some things. Am I supposed to talk about this slide? Okay. So one of the things that we used, or what the city of Los Angeles was able to use in terms of information that led them to this approval, was some work that was done back in, I think, 2016 or 2017 now, by Dr. Amy Serrato at the University of Oklahoma. She led a very comprehensive test program that was sponsored by the DFI Helical Piles and Tiebacks Committee, where we actually were able to do tests on the shake table down at UC San Diego. It's the largest outdoor shake table in the world if you've not been there. So we had a big soil box on the table. That's what you see there in the lower left-hand corner. So Hubbell Chance, among other helical pile manufacturers and contractors, were able to get on the table for a couple of weeks and do a bunch of shake tests and simulating various seismic events over time to see how well they responded. We used that data from those shake table tests to develop those tables that I just showed you. So I probably should have had this slide first. So I apologize for having this out of turn, but that's where a lot of this information came from. All right, Fernanda. That's it.
Yeah, here if you're interested to get additional information, you can use the QR code. We have a nice case study below, like a video that Gary just mentioned about the shake table test, our ICC report on the top right, and then a cool article about helical piles used for earthquake remediation. Just a little bit history here. Despite what a lot of people think, helical piles are not new technology. The first recorded screw pile was done by Alexander Mitchell in 1836, first for boat mooring, and then for the Mapling sand lighthouse in England. And today, helical piles are being used worldwide for many different applications. Why Chance? Because we are the best helical pile manufacturers out there, but
You're not biased, are you?
but we at Chance, we have over 150 years of combined engineering experience to help contractors and designers with your design. We provide engineering stamps when it's required. We have at least 40 years. We've been manufacturing at least 40 years longer than any other major competitor out there. And if you don't know yet, we have a really nice software they call Helical. And you can just go to our website and download free of charge. And you can use the software to help you to design your project with helical piles. And all our material is made in the USA as well. What questions do you have for us today? Thank you. Ask Gary if you have questions.
Thank you very much. My understanding is that all those studies were done on piles installed vertically, right? And the lateral capacity that you provided takes into account the installation depth of the pile as well, right? And in those cases, can you attach a lateral load capacity to the already published compression or uplift capacity of your piles?
Yeah, and that was the intent of that table, was to provide you with those lateral capacities based upon those soil types. And so we didn't necessarily do every single soil, options, but we just wanted to give people a range between stiffer materials or softer materials to give a sense of that lateral capacity. But you're exactly right. This was somewhat outside or independent of the actual capacities of the piles. That's what our intent was to do it that way. So.
And based on the presentation, my understanding is that for lateral for applications where lateral capacity is a must, meaning, for example, LA applications, the soil report is absolutely mandatory, right?
Correct.
Okay.
Yeah, that's actually been part of the evaluation of, in our case, with our evaluation since we first got evaluation reports.
Thank you.
Yeah, thank you. Good question.
Any other questions? Great.
Hi, I'm sorry I got here late. I don't know if you covered this earlier. Did you cover liquefaction in any way?
Not in what we talked about here.
Has any liquefaction testing been done, or is it planned to be done?
Good question. Just came from a presentation in Christchurch. They were talking about shear wave velocities, but I'm not sure that they really I didn't hear them talk about that. But In this particular case, Bill, I'm not aware. Good question to ask.
Okay, thanks.
Anyone else? Well, thank you guys. All your fans showed up, so I hope you.
Yeah.